But what we're expecting is climate. So is knowing how much weather has deviated from the long-term average. The key issue for climate monitoring within this region is the lack of data. Satellite data could fill in the gaps that the sparse observing network within the region brings in. But to realize the full potential of satellite data, what we need is a verification of the data and adapting algorithms that have been developed for other regions to our region.
In Africa, most of the country use satellite data because they are more regular and more accurate. But before using them, you have to calibrate them with ground observation data. After that, you can put the satellite data into the models to forecast weather or climate for different purposes. EUMETSAT supports the African countries by providing them devices to receive satellite data, by training the personnel, and through the framework to exchange knowledge and his success history.
The main benefit of this cooperation with Africa over the last 30 years is that African users have access to loads of data that help them to better make weather forecasting, to better manage the environment, and also to have a look on the climate change and variability for the years to come.
Hello, and welcome to session 2 of the webinar, African Climate Monitoring from Space. This session is targeted at decision makers and users. My name is Mimi Amachi, and I work at the Skier division at EUMETSAT, assisting in matters regarding to EUMETSAT's cooperation with Africa. So before we start, just some information on the technical aspects. First of all, Zoom. Many of you are already familiar with Zoom as a tool in general, but let me still repeat some of the functions which are important for this webinar for any new viewers. So first, this webinar is going to be bilingual. So if you go down to the panel, and if you see the last icon interpretation, you can choose between English and French, and you're also able to turn off the original audio. So there's the button which says mute original audio. And if you feel that the original audio is kind of disturbing you, you can also totally mute it. And second, also be aware that this meeting is being recorded and live streamed on YouTube. Our next important tool is Slido. So we're going to share the screen right now. So there's also a translation function for our French speakers and for our English speakers. And just for information, this is also being recorded, and it's also you can raise your questions here. And it's important to use our hashtag EO Africa. So E is in capital letters, O2 and Africa is written normally, and we're going to add it in our chat. So, and if you put in that hashtag, you come to the landing page, and please add your name, because we're also going to have a poll which is going to be following you throughout the entire webinar. So as you see, you put in the hashtag, which is also in the chat at the website. And then you can also watch our video from the website itself, but then you won't have access to the translation. And you can see there's the Q&A. So whenever you have any questions, put your questions here, because the Q&A function is going to be turned off on Zoom. So whenever you have any question, please go to Slido and raise it there. And then on the other side, we also have our polls. And we can start our first poll today. So I think I'm just going to start asking in the round. So please, I'll ask everybody to go to Slido and to put in the hashtag and then your name. And the first question is, on a scale of 1 to 5, how are you feeling today? So just put in your scores. And I'm going to tell you how it went out afterwards. So next, there's also some information for the YouTube stream. So it's going to be streamed on YouTube, and you're also going to be able to watch it afterwards, after the entire thing is over. And I'm also encouraging you to use the social media hashtags, hashtag EOAfrica and @EUMETSAT whenever and just post about it. And the agenda can be found in your emails. And if you want to have more information on the agenda, you can also go to the registration page. So with all that said, I would officially start session 1 and give the floor to our DG, Phil Evans, for a short introductory words. Phil Evans, the floor is yours.
Thank you. Dear colleagues and dear moderator, it's a real pleasure to be here today and for me to welcome you to this second webinar dedicated to our user community and partners in Africa. Even though, as we're all getting increasingly used to, it's through video conferencing rather than a face-to-face meeting, but it's the best we can do. Just to say, as the new DG for EUMETSAT, I give a particular priority to engagement with our partners and engagement with our user community to ensure that we get the maximum benefit from the investment in our satellite systems. After having discussed the potential benefits offered by MTG for Africa during the first webinar in March this year, this session will now focus on the satellite contribution to climate monitoring. Obviously, as everyone knows, Africa is the most susceptible continent to climate change due to the, well, for many reasons, but due to the predicted increasing frequencies of natural disasters and the impact on economies and the consequent loss of life. It's obviously of crucial importance for governments and decision makers to define and implement appropriate mitigation and adaptation policies. And this is only really, I mean, these need to be strongly evidence-based, and this is only possible through a better understanding of climate change, its impact, and the development of evidence-based, science-based climate services. EUMETSAT has operated the Meteosat satellites over Africa for more than 40 years. With MTG, we'll extend this series to 60 years and beyond, which is quite remarkable. On this basis, EUMETSAT provides climate data records, which are consistent and calibrated time series of satellite observations. These data records allow the monitoring of various essential climate variables, such as precipitation, albedo, and winds. In Africa, ground-based weather and climate observation networks aren't as dense as we would all like them to be. So I think, therefore, satellite data is a precious source of additional information and can greatly facilitate the understanding of climate change over the continent and support the delivery of climate services to support regional and national agendas. Of course, the challenge lies in ensuring the uptake and usage of satellite data in Africa is able to support the provision of climate services to community and support the implementation of the Paris Agreement. To tackle this challenge, we are very pleased to cooperate with African institutions such as ACMAD, the Regional Climate Centres, the African Union Commission, with the European Commission. And the key word in all of this is partnership. I think it's so important and so crucial to understand users and make sure that we're supporting that community as much as possible. So with that, I'd just like to say I wish you all a very productive and enjoyable webinar, and thank you for your time.
Thank you very much for your introductory remarks. So before we continue with our first presentation, I'm going to please go back to the Slido, and I see some of you have already answered. So I see most of you are feeling wonderful. So most of you are at the 5, some of you at the 4, and a very small amount of you are just feeling okay. So that's really good to know. So before I'm going to come up with another question. You have time until the next intervention, which is going to be after the presentation of Mr. Jolie Wasambo. So I'm going to put up this survey poll. The first question is just a cloud poll, and it's the question, where are you joining us from? And the second question will be, what institution you work at. So with that said, I'll start with our first presentation, and this would be from Jörg Schultz, who works at EUMETSAT in the climate service, and he's the product manager at EUMETSAT. and also the Managing Climate Services, and is going to have a presentation on climate monitoring from space. So Jörg Schultz, the floor is yours.
Yes, good morning, everybody, and I hope you can hear me well. And Mimi is sharing the presentation. So, as Mimi said, my name is Jörg Schultz, and I'm leading the Climate Service Support Unit within EUMETSAT, producing many of the data records that Phil was just talking about. So I will try in 10 minutes to bring you a bit up to speed on systematic observations from space in support of the Paris Agreement, which is of course probably the most important political agreement to keep our Earth in shape for the future generations of human beings. Next slide, please. So what we know is, of course, that observations are really the foundation for commitments of the parties in the UNFCCC, and also on decision making on climate change. And you see, I have four big blobs there, which are really inseparable, connected. And you see on the left side, so observations, and I just left this mostly to the space sector. So where space coordination mechanisms like the Coordination Group for Meteorological Satellites, CGMS, or the Committee on Earth Observation Satellites work together to make satellite data usable in the context of the Paris Agreement. And we use, of course, frameworks like the Global Climate Observing System, also sponsored by WMO. Well, we also have on Earth a lot of research organizations, and they are actually needed to make the right progress to understand the Earth system. And they, of course, also use largely observations. Then you also know the Intergovernmental Panel on Climate Change that brings out assessment reports on the status of the climate systems and its future evolution, which is, of course, very important for the politicians to see how the future would evolve if they act as they act, or what they need to change in their acting. And then, of course, there's policy making within the UNFCCC, where all the member states of the United Nations Framework Convention on Climate Change interact and discuss what the actions actually will be. If you look into the Convention of UNFCCC, there are just two articles that are very important. One is the commitments that the individual member countries need to make. And there's Article 5 that is really set up the stage for the need for research and systematic observations, or in short called RSO in the UNFCCC context. And that's basically where EUMETSAT and also other space agencies contribute. In the Paris Agreement itself, there's one article which is actually labeled under adaptation, where you can see that everything that's in these pictures and at the top is included in one article. And this is really calling for systematic observations of the climate system, but also for early warning systems, so that you are protected against consequences of climate change. Next slide, please. So, just talk about one part of the Paris Agreement, and that has everything to do with mitigation of emissions of CO2 and methane and other trace gases that lead to global warming. So if you look into so-called greenhouse gas inventories, which are really an essential part to be considered in the so-called global stocktakes of the Paris Agreement, which describe what the progress is that we all collectively make in implementing the Paris Agreement. So if you go to the bottom of the slide, so every country is providing their emission estimates, and this is sector-specific estimates of emissions from known sources like industry and traffic and all these kind of things. But Earth observation play a critical role in that. For example, for tracking land use change. You see this land use map, a global map, which is largely done from satellite data. And of course, space agencies provide those data, so play already a role even in these bottom-up inventories, as we call them. What we also try to do is, of course, to do what we call top-down inventories, which means that you rather start observing the CO2 in the atmosphere and then go down with models to the surface and determine what the fluxes at the surface will be, and also what the emissions will be. So this is interesting in actually provide integral constraints on emissions of individual areas and we can detect changes from the natural carbon cycle with this, but also caused by human activities and climate change. Next slide. So Europe has currently a very big activity, and you see all the logos down there from Copernicus and ESA and EUMETSAT, ECMWF, following a system approach to deliver atmospheric CO2 and methane inventories. And you see in the left panel there, there's a lot of observational input into a data assimilation system that provides them distinct outputs, which you can see on the right, that really range from hotspot detection of emission sources, but also not neglecting the global picture and how the global fluxes are going to change. So it's a complex system that needs many actors to interact in using the observations to bring out the products that are actually needed to support implementation of the Paris Agreement. And currently, the international community is doing a kind of pilot products for the first global stocktake of the UNFCCC to see how they can be used best. Next slide. In this context, so EUMETSAT is involved in preparing one of the future Copernicus mission, which is called the CO2M mission, which has exactly the objectives that I described on the output side on the last slide. And currently, so the design of the satellites is ongoing and all the product definitions. And the launch of a constellation of satellites is planned for late 2025 to have some real, actual, very much improved data in hand then for the second global stocktake, which will take place in 2028, but the data actually needed much earlier. Next slide. So what I showed you on the mitigation part is actually one part of a much bigger picture, which is the architecture for climate monitoring from space. And this is what you see here. It's depicting the value adding flow of how you use remote sensing data that we produce climate data records that were mentioned earlier. And you saw a couple of examples, I think, yesterday in the presentations, being used in applications like seasonal forecast or reanalyses and similar things, leading to information that can be used for decision making. Next slide. So this slide is showing how this architecture is actually implemented at EUMETSAT. Just as an example, other agencies do similar things, but we do this very systematically. So on the left side, you see basically all our satellites and instruments that are really maintaining the very long series of satellite data that started for EUMETSAT basically in 1977 with the first Meteosat satellite. And the portfolio of observations has been increased largely over the years. Then we produce a lot of climate data records at the EUMETSAT Secretariat, but also in our satellite application facility network. And this is where you have seen examples from yesterday. The applications that we serve is, of course, in national climate services providers, but also European-wide services providers, but also research. And this is really addressing things like you see in the little list there on climate variability, trends, extremes, changes in extremes, but also climate processes, so to really further understand the Earth system. And there's still a lot that one needs to understand, and this will never end because this is just science that is behind that. But also how to drive climate models to get these longer term predictions on decadal scale, but also still projections on century scale. And then decision making is using that. And UNFCCC is just one example, but there are others which are more local and national, like for infrastructure, energy, agriculture, fisheries, and so forth, where these results of the service providers are being used. And I think some of you are really involved in providing those services in your area. Next slide.
That will work. Could you maybe speak a little bit slower for the interpreters to catch up?
Okay.
Thank you. Thank you.
Thank you, Mimi. Yeah, so what we can do is to derive a lot of variables that describe the Earth's system. And this, what you see on this slide is that the Global Climate Observing System has defined what is called the set of essential climate variables. And here we have marked all those in purple, so which we can actually retrieve from satellite data. So in total, we have about 54 of these essential climate variables, which have still sub-products. And from space, we can basically address about 37 of those in principle. And at the moment, we provide about for 35 of them data records from various satellite instruments. So you see that there are, of course, weaknesses in particular in subsurface ocean physics, so which is just telling you that from space you can't look really deep into the ocean, and that will always remain. So there will always other data needed. And for some, of course, spatial resolutions are not good enough, so that you would still need some ground-based data to characterize, in particular, very local and regional changes, in particular, if you want to look into things like adaptation. Next slide. So just one example of a product that you may have not seen yesterday, and that is still under development with a partnership with Ligos in Toulouse in France, is a monitoring of the global convection system. And this is what I think most of you know, the mesoscale convective clusters. So what we try here is really to elaborate a climatology around the globe. So what you see is just from EUMETSAT, but we do this for all geostationary sensors, and to really have a good database of these mesoscale convective systems. And this, of course, this software that is behind that can also be run in real time. So, and that will really enable probably supporting what you have, what you need for seasonal outlooks, because you can connect this with other satellites' precipitation estimates, but you would have a very good knowledge about systems, where they travel, how often they appear, how big they are, how long they need to build up, how long they need to decay. And this is really all part of this database. And we work on that to have probably a product within probably 1 year from now. And then we need to work how to bring this into usage also in Africa. But I think it's pretty interesting. And if there are needs to run this with higher timeliness, that could also be probably attempted. Okay, next slide, and I think that's my last. Yes, so the key messages I think from this presentation is that that the use of space-based observations with undoubted quality in the global stocktakes of the UNFCCC and the Paris Agreement can play really a supporting role, providing evidence for the success of the implementation. And the constellation of the architecture of monitoring carbon dioxide and methane, that really supports directly the Paris Agreement, including the development of the national inventories. And we encourage all parties of the UNFCCC, and some of you may also belong to those parties, to continue the support and for the development of this constellation architecture. And so, as I said, we bring together top-down and bottom-up emission estimates, and the space agencies and other service providers grant full, free, open access to the data, which will be available for use by all parties. So space agencies also provide long observations for 35 out of the 54 GCOS essential variables, and that shows you that it is not only about carbon and methane and other trace gases, but it's really for measuring the Earth system. Also for those, we know from activities in inventorizing our data records that the data access is globally full, free and open for more than 98% of all the data records coming from various agencies, which is actually very good. So there's no problem in having access to the data. There might be a lot of technical problems in utilizing the data, and that is a very valid question that might need better addressment. So the systematic implementation of the architecture for climate monitoring, so from space at EUMETSAT, enables us to provide about 25% of all the climate data records available globally. And so we are indeed a major player in providing these data sets to the world. And that's all I have. I thank you very much for the attention. Mimi, back to you.
Thank you very much for your opening presentation. Next, we'll move on to the presentation of Jolie Wasambo. He is the project coordinator for climate services at the AUC, and is going to have a presentation about policy and strategic perspectives and CLIMSA contribution. There will be time for questions and answers, and that's going to be after the presentation from André Kamga. So, Jolie Wasambo, the floor is yours.
Thank you, Mimi. Thank you, moderator, as the presentation is being loaded. My name is Jolie Wasambo, as she said. I work for the African Union Commission on meteorology and climate issues. Next slide, please. Yeah, I'll be giving this presentation, especially on the contribution of space climate monitoring to the achievement of Africa's sustainable development goals, as well as the Africa agenda for development, that is the Pan-African vision. That is about the assurance that by 2063, where do we want ourselves to be? So in brief, what I'll be presenting is one, I will highlight the significance of climate monitoring from space, as highlighted in African policies and strategies, as well as some other instruments, and also provide a brief summary of provisions of those policies and strategies in relation to space climate monitoring. And I will exemplify the intra-ACP climate services and related applications program in highlighting the relevance of space climate monitoring in achieving Africa's strategic goals. There I'll be highlighting the added value that the CLIMSA project brings to these African programs. Next slide. As I said, the whole Africa now is governed by a Pan-African vision, as it is articulated in Agenda 2063, where we aim at having an Africa that is well integrated, that is well prosperous, and that is peaceful, and that its own citizens are at the forefront of driving its all businesses, and that in the international arena, the same Africa has a voice. By doing so, in achieving this one, there are a number of instruments, strategies, decisions made by the assembly, that is heads of government and state. There are policies and strategies. There are numerous declarations that have been made. I'll be highlighting some of the provisions from them. Just a few of them I've mentioned here, and they are forming what I'll be presenting. Next slide. Yeah, so when you look at the Africa Agenda 2063 in relation to space, or in relation to exploiting space for sustainable development in Africa, you'll find out that the whole African vision acknowledges that Africa is increasingly dependent on space as far as its economic development is concerned. And you also see that these instruments recognize the importance of space-based products for Africa's socioeconomic development. That is in various fields, that is in agriculture, climate, communication, disaster management, marine bioeconomy, and the like, health and others. And also these guiding principles consider new developments in satellite technologies as critical in facilitating access of Africa, of access of space-based products and services, and that space technologies are highly regarded as an instrument offering a unique opportunity for the continent to collectively address its social economic development issues. Next slide. Now, what has the high political leadership said about space, especially regarding climate monitoring and development? Number one, what they've done is that they are really concerned about the vulnerability of the continent in areas of socioeconomic development, its productive systems, people's lives and property and the like, and that the low capacity of the continent to respond and to mitigate these effects is also a worry to our heads of state and government. And because of this, one of the things they've done is to call for integration of climate change considerations into development strategies and programs at all levels across the continent, whether at continental level, regional level, or even at community level. But when you look at that, what is the need therefore? You recognize that for that to happen, the need is that the continent needs to have adequate science-based and timely weather and climate information. That is the need that we have. Next slide. Therefore, despite the need, what are the challenges and what is the situation on the ground? So these instruments recognize or identify a number of constraints or challenges. Number one is that we have sparse or obsolete observation networks. this is acknowledged at strategic level, that the cost is high for climate monitoring, especially when you look at infrastructure space, that there is a need to have institutions and the requisite human capital. That's an issue that we have. Technologically, we are also having an issue. We need to have technological capabilities to exploit the outer space for our civilian needs. And that also on the same technology that although the outer world or the other developed world is coming up with advances in science and technology, we are having limitations in accessing such, while climate is still a major challenge for the continent. So those are what are being recognized in Africa's policy and strategic instruments as challenges and a situation that we have to deal with. Next slide. Now, in order to move forward as a continent, looking through the strategies, looking through the declarations, looking through the policies, what is it that we're getting from those provisions and instruments? Number one, it is acknowledged that meteorological satellites or space-based technologies are critical for monitoring of weather and climate, as well as for delivering weather and climate services. The other thing that is being highlighted as strategically important is that international partnerships, both now and in future, they are very critical, and they play a critical role now and they have to play the same in future. And that initiative like the CLIMSA play a critical role in ensuring or in providing coordinated mechanisms to enhance the production and delivery of weather and climate services that we are dire in need of at this present moment if we are to move forward with our development agenda. Next slide. In addition to that, the continent recognizes that there is need to have weather and climate services delivery as a key issue as long as building resilience and adapting to climate change is concerned. And recently, our ministers have come up with an undertaking or a commitment to say that EUMETSAT third generation satellites are seen to be critical in providing significant improvements to space-based monitoring of climate on the continent to support our development efforts. And that we need tailored climate services for the continent if we are to have pinpointed or effective development in all our areas or our subsectors. And as such, our heads and our ministers have said there is need, therefore, to develop and establish an African meteorological satellite application facility in order for the continent to be able to come up with the tailored climate service, weather and climate service. This is the declaration of our ministers responsible for meteorology. Next slide, please. Now, regarding that, so how does MESA come in to add value to these policy issues and strategic issues that have been just highlighted? Next slide. Just a brief, the CLIMSA it's an EU-funded project to the tune of 52 million for Africa and 85 million euros for the whole Africa, Caribbean, and Pacific. And is funded through 11th European Development Fund within the Africa-EU joint strategy, and also through the Organization of Africa, Caribbean, Pacific States. And its aim is to address the very need which we highlighted, that there is need for reliable, timely, and adequate climate data and information in the face of obsolete networks and sparse observation networks. And when looking at it, it also responds to the Paris Agreement on climate change, specifically on the area where it says strengthening of scientific knowledge on climate, including research, systematic observation, and climate systems and area warning. This is what the just foregoing slide presentation said. And also the CLIMSA project strengthens synergies with other existing initiatives, and it's one of the major space-based climate projects that Africa is implementing at the moment. Next slide. Now, just for information, the CLIMSA project in Africa fosters sustainable development by improving decision-making processes and practice to informed adaptation options to climate variability and change. The purpose is to ensure that the entire climate services value chain is strengthened, whether I talk of information generation, application use, user interface, and the like. Next slide, please. And as expected results, there are 5 expected results, which include user interface platforms. If you look at all these 5 results and the challenges I just highlighted before, which our strategic documents say, find that all these respond to that. You have user interface platforms, establish them so that there's much interaction and co-production. You need climate services to develop and distribute them. You have to access, need technologies there and the like. We need to enhance our capacities, institutional infrastructure, as well as human. We need to inform policy and decision making. That is where we have also to talk of mainstreaming climate information into our programs, decisions, and policies. Next slide. Next slide, please. Yeah. So as a final slide, this is my final slide with information. What then, therefore, is the added value of the EUMETSAT project excuse me. What then is the added value of the EUMETSAT project, all the strategic provisions that I've just laid? Number one, we have seen that it's well important in providing a coordinated mechanism for enhanced production and delivery of climate-based, science-based climate information and services of the continent. And secondly, it's there providing us with tailored or sector-specific information for us to move ahead with our socio-economic development in various sectors. And it also supports continuous monitoring and appropriate forecasting of severe weather and extreme climate events. It helps to strengthen or develop institutional and human capital, and supports and makes some contribution to technological capabilities for us so that the continent, especially NMHs, are capable of exploiting space or exploiting space-based weather and climate monitoring, and also strengthening partnership with the EU, with EUMETSAT, have an MOU for that in order for us to be able to access that information and data. And then it's also supporting a smooth transition from MSG to MTG by providing preliminary infrastructure to member states. And it is a precursor to establishment of the AMSAF by way of its tailored climate services that is being produced now. Next slide, please. So that's what I had, Madam Moderator. Thank you for the time, and thank you, colleagues, for listening.
Thank you very much for your very insightful presentation. So before we move on, I'm going to refer back to our Slido, because now we've got in some answers. And let me just show you the results of this poll. So most people have already given their answers. Oy, oy, oy. And most of the participants are from South Africa, Germany, and I see some France, Kenya, from the Seychelles. Hello, everybody from everywhere. I see Ghana, Nigeria, Dubai, Rwanda, Poland, Italy, Gabon, Madagascar. Thanks a lot for joining us from everywhere. And most of the people are coming from the Kenyan Meteorological Department, EUMETSAT, METALSAT, and the SMA and the SAWS. Welcome everybody, that's really nice to know. So we're gonna continue with our last presentation before the question and answer. And this is going to be from the DG of ACMAD, who is Andre Kamga, and he also moderated yesterday's first session, and is going to hold a presentation about the overview of climate services. Andre, the floor is yours.
Thank you for having me. Yeah, so this presentation is basically an overview on satellite products and climate services in Africa. We'll see some new developments ahead. Next slide, please. What are the challenges in climate monitoring in Africa? What are the opportunities for products with the satellite observations? And then there's some statistics on tracks and intensity of storms. We'll discuss, for example, the issue of, as you saw in the previous presentation, of having every year an archive of tracks and genesis areas of mesoscale convective systems in Africa, and some key messages for the future. Next slide. So here you have the network of stations measuring different parameters, synoptic stations, and particularly precipitation. And here you can see that more than half of the stations are not operating regularly. So this is the output of a station monitoring report that ACMAT issues every month. So this is valid for April 2021. And you can see that over Northern Africa and the Southern Africa, you have a dense network of in situ observations. But in between, we have some challenges that should be in some way addressed with satellite data. Next slide, please. So these are opportunities now that we have with satellite data. On the left, it is the use of satellite-derived precipitation to determine the climate zones across Africa. And on the map, you can easily see the desert, the arid lands, and the very humid forest area over Central Africa. And having historical records of satellite data since the 70s allow us to look at the shifts in these climatic zones from one year to another, and then actually detect some climate change signals. On the right, it is the use of these same satellite-derived rainfall for drought monitoring. And you can see here for 2020 over North Africa, areas in orange to red are considered as dry area during the year. And you can also note the Sahel band from Cape Verde to Djibouti, very, very wet in 2020. So this shows that the satellite products can be efficiently used for drought monitoring at continental scale. Next slide, please. So this is the use of effectively the satellite-derived rainfall to look at the shift or the changes on the climatic zones on a year-to-year basis. So on the right, it is the climatic zones for 2020. And then on the left, it is the average. One can see that 2020 was characterized by a great expansion of the very humid area across Africa, actually touching Eastern Africa. And our Ethiopian Med Service colleague here was actually indicating that this small area over Ethiopia, characterized by a humid climate in 2020, is not usually under that climatic zones. And it indicates the connection between the Ethiopia and the Congo basin in particular. It's studies have demonstrated that in some years, one can see a clear connection between Central Africa humid zones and the parts of Ethiopia. Next slide, please. Showing here the needs for us to actually integrate the continent in this specific sector. So this is another product which was developed using seasonal forecasts and sea surface temperature as predictors, indicating the last severe drought that we had in over Southern Africa in 2015-16. And this product was made available around November 2015 with information on the expected hazards, the potential impacts, and the measures proposed for action. Next slide, please. Okay, but we have a challenge in using this product because for that event, that significant drought in 2015-16 over Southern Africa, we had the first high-level political declaration of a drought emergency at the SADC level in July 2016. That is actually after the end of the drought. The message here is that even in the country, some countries declare drought emergency in April 2016, and some try by December 2015 to issue a national declaration. So we usually put this to highlight the need for us to actually raise awareness and work a lot on the user interface of the current intra-ACP climate services program to make sure that there is little delay in actually acting on what our products, some of which are coming from satellite data analysis, are telling us ahead of time on different hazards, particularly drought. Next slide, please. Yeah, so this one also shows two products from a policy paper by UNECA. On the left, it highlights over our Iceland states the number of people affected by extreme events. And what you can see is that this number of people affected by extreme events are computed, are generated using satellite observations of flooded area and so on. And on the right-hand side, it is the statistics of number of cyclones. And you can see 2020 was characterized by an exceptional high number of cyclones and storms in the Atlantic. So this exercise, we will be developing it for mesoscale convective systems that you have seen in the earlier presentation over different locations in Africa. And this helps us to see the changes on the tracks of these systems or their intensity much more effectively in different countries. Next slide, please. Yeah, this is the most important product that we wanted to share with you in this presentation. It is a monitoring and outlook on the onset of the rainy season. It is issued every 2 weeks, monitoring areas which have already had their onset, if that onset was late or early or normal, and then providing an outlook over the upcoming 2 weeks, how the onset will be. So for the interpretation over Niamey, where we are experiencing a significant delay on the onset, and you will see on the Niamey location that we have a red star that we could identify by analyzing precipitation, daily precipitation derived from satellite data since the 70s to actually get this part of this information. So we really encourage all the Met services to connect to the ATMAC website every 2 weeks and look at how the onset of the season is unfolding over different locations in their countries. Next slide, please. So this is another application of satellite data, actually over the meningitis belt of Africa. Humidity derived from satellite data as well as dust derived from satellite data has been used at ACMA to generate vigilance map for emergence of meningitis cases, and a pilot exercise in Niger over health districts, as you can see here, help to actually determine the level of vigilance to consider for each health district across Niger. And this is an exercise that we want to pilot in the upcoming GFCS program in other countries in Africa. Next slide, please. So as I said, dust from satellite as well as humidity derived from satellite products are used for meningitis vigilance products at ACMA. The other important product for policymakers that is derived from satellite data is the determination of warming levels and rates. As you can see here in red from the State of Climate Report for Africa in 2019, we can see the changes on the rate of warming over Africa from different series of 30-year periods. And one can note that for the most recent 30 years period, the warming rate reached 3 degrees per century over Africa as a continent. And given the fact that the satellite data is of high resolution, we will be working with the countries, the pilot countries in the GFCS program, to actually look at the warming rates at the country level, and particularly in big mega cities that we have in Africa, for our policymakers to understand and have all the elements necessary to undertake climate change policy debates. Next slide, please. Yeah, so this is just sea surface temperature for 2 periods, the last 20 years and the 20 years before, starting in the 1980s. And what we want to highlight is that this product is generated using also satellite data. And we can see that the most recent 20-year period was characterized by a tendency of more cooling across the coastal part of Southern Africa and the westernmost part of Western African coast. And these signatures have been related over West Africa with a higher frequency of delay on the onset of the rainy season in countries over here, and more intense drought over Southern Africa, the most significant one being the 2015-16 drought over Southern Africa. So the sea surface temperature trends that we are seeing is related to the intensification of those extremes. Next slide, please. Here it's just the number of very hot days over Africa since the 70s. So as we said, this parameter is also have also satellite data as input for its generation, and one can see the trend on the number of very hot days over Africa. We move from about 2 days in the 70s to more than 10 days over the recent years, meaning that we'd like in the early warning systems that we'll be developing for Africa, put emphasis on the hot days and heat waves as part of the major hazards on which we should develop early warning system. So as you can see there, the satellite data is very useful to identify what is the priority for the continent in terms of developing multi-hazard early warning systems. Next slide, please. So this second slide shows the same picture, but for heavy rainfall. So we also have a situation where we move from about 4% of the African land masses hit by heavy rainfall in the early 80s to up to 40% of African land masses was touched by heavy rainfall in 2020. So this is a second major hazard that should be our priority in the early warning system development for the continent. Next slide, please. And satellite data is very key in actually appreciating the intensity, the severity of rainfall. So these are the few key messages that we want to share with you after this presentation. So to address the observation gap, in situ observation gap today, we will have to rely heavily on satellite data. And we have seen evidences of the use of satellite data to determine the warming rates across Africa as a continent. And given its high resolution, it will be possible to apply it even to understand the warming in the African megacities. Satellite data has also contributed to detect significant precipitation in the continent, across different parts of the continent, and the trends that we have seen in precipitation as well as very hot days. Next slide, please. sea surface temperature, as we saw, is very important for understanding some extremes, drought and floods. And we have shown evidence of actually archiving this data derived from all the history of satellite that we have to actually understand the severity of drought and other extreme events we are experiencing across the continent. Thank you very much for listening, and we have some challenges ahead with the use, the efficient use of satellite data, and we are keen to work with all of you to develop what is necessary for our continent in this regard. Thank you very much.
Thank you very much, Mr. Kamga. This is a very inspiring presentation. Now we move on to our question and answer session. So you can post all your questions on Slido, and you're also able to upvote some questions which you find very interesting and which you really want to be answered during this session, because we're having some time constraints. We can't answer all of them, but we'll get to as many as possible. And questions we can't answer live are going to be answered later on. So the first question I see which is upvoted is from Cedric Elsie, and he asks, what strategies has the AUC done to enhance climate network with new weather observations? And I think this question would be targeted to Mr. Jolie Wasambo. Mr. Wasambo, if you can answer it. Okay. He doesn't seem to be here. Does anybody else have any information on this, or should I just move on to the next question? Okay, I think I just move on to the next question, and he's going to answer it online. So you're going to get your answer on Slido. So the next question is from Mr. Mangura Seiduba, and he says, I think you will have to think about training project on MTG in Africa. Thank you so much for understanding. Another one is from Rivo, from the NMHS Madagascar, our winner of yesterday's quiz. And he asks, what are the criteria used for onset and cessation evaluation? That parameter seems very crucial for agriculture. Thanks in advance. So maybe Andre, if you can answer it.
Yes, for the onset, which is the first parameter on which we are working, we are not yet looking at the cessation. That will be an objective during the GFCS implementation. So on the onset, we undertake this holistically. We first take the definitions used by the agricultural sector in the countries, and then the definitions from scientific peer review publications in different parts of Africa. And then a third definition that we borrowed from the Bureau of Meteorology in Australia. And then we are applying all these definitions in the assessments, having available our long historical records of satellite data and the derived precipitation. We are actually able to see the deviations from the average onset dates that we then actually put in these maps. So we are also running a training program on that, actually online, for people in all the med services who may not be able to send people at ACMAT to actually understand the approach and apply this methodology for the onset. Thank you.
Thank you very much for this answer. Another question we have is from Mahamadou Adamu. It's a friend, so beg my French in case it isn't that good. So his question is, pour la carte de vigilance de la méningité, est-ce que vous avez données cliniques pour voir la pertinence? That would be a thing for André too.
Yeah, I will respond in French for him to understand well. Oui, dans cet exercice, nous nous sommes appuyés sur des travaux d'un programme qui s'appelait Mérite de l'OMS, qui a montré les liens entre les paramètres climatiques dont on a parlé, c'est-à-dire la poussière, l'humidité, les vents et l'émergence des cas de méningite. Donc, ces produits ont été validés notamment au Niger. Comme vous avez vu, nous avons eu une phase expérimentale avec le service de contrôle et de la surveillance de la méningite du ministère de la Santé du Niger pour exploiter cela pendant la période épidémique de la méningite. Et ça permet de comprendre, de déterminer les districts sanitaires à haut risque et de mieux orienter les traitements et même les vaccins. Et c'est une initiative que nous allons essayer de déployer dans les autres pays pendant la mise en œuvre du programme JFCS en cours. Merci.
Okay, thank you very much. And so we're gonna get the question from Cedric LZ, and he asks, please, I want to know, how can we predict GHG forecast for local country as Cameroon? And that would be for Jörg. If you could also answer it live.
Yes,
thank
you, Mimi. Yeah, I answered this in the Slido, but I think so. The forecasts probably are done by the Copernicus Atmospheric Monitoring Service, and if you look at my answer in the Slido, I provided a link to this service, and so I don't know exactly for which greenhouse gas they issue forecasts. But please go to that webpage. I think it's very instructive to find some forecasts. I found one for carbon monoxide, and I found others and trace gases for atmospheric forcing. And so this is the source of the forecast data. And I think they have that data also in a kind of a data store. I think that can be used to cut out also individual countries or areas of interest. So I think it is, so this is all and served by our partners in ECMWF, and that would be the address to search for a forecast.
Thank you very much for your answer. So before we move on with our next presentations, I'm gonna refer you back to the poll. So we've opened another poll, and it's just a question, what do you do during online meetings? So you have time. So I'm going to give you some time until some presentations are over, and then I'm going to show you the results. And okay, this would conclude this part. So now we can start with our user cases. So this is section 2 of today's section 2. And the first presentation is from Dr. Isufu Power, and he's the expert analyst in food security for Cadre Harmonisé for Synthesis and AgriMed. And it's going to have a presentation about Cadre Harmonisé. And please, I'd also ask my presenters for this section to please keep the time in mind a little bit so that we don't go so much over time. So, Mr. Bauer, the floor is yours.
Ok, merci Image. Mon nom c'est Bao Issoufou. J'espère que vous me recevez bien. Je suis expert analyste en sécurité alimentaire chargé de la mise en œuvre du cadre harmonisé. Et le cadre harmonisé, c'est un outil qui est similaire à l'IPC, orienté vers l'analyse de la sévérité de l'insécurité alimentaire et nutritionnelle aiguë. Et donc, selon une échelle de classification standardisée qui est aujourd'hui en vigueur au niveau international et qui permet effectivement d'analyser la sévérité, d'identifier les populations en insécurité alimentaire et nutritionnelle et de formuler des recommandations en vue de faire des actions. Ma présentation sera centrée sur quelle utilisation on fait en fait des produits d'observation de la Terre dans les analyses du cadre harmonisé. Donc, c'est autour de 4 points. Prochaine slide. Comme je l'ai dit, le cadre harmonisé et l'IPC sont deux outils similaires qui ont le même cadre analytique, bâti sur l'analyse des résultats de la sécurité alimentaire, ce qu'on appelle la consommation alimentaire, l'évolution des moyens d'existence, le statut nutritionnel et la mortalité. Et tous les facteurs, si vous voulez, déterminants et les facteurs limitants qui expliquent les changements dans le comportement des résultats de la sécurité alimentaire, notamment l'analyse de tout ce qui est éléments de choc, que ce soit les chocs climatiques, les chocs sociaux, etc., et les termes, en termes de vulnérabilité au niveau des populations, et les 4 dimensions interrelatées de la sécurité alimentaire qui sont la disponibilité, l'accès, l'utilisation et la stabilité. Et on essaie de regarder le tout dans une logique de ce qu'on appelle la méta-analyse, qui est basée donc sur un ensemble de protocoles et qui permet de valoriser l'ensemble des données disponibles, que ce soit des données biophysiques, des données socio-économiques ou même des données qualitatives descriptives. Et c'est dans ce sens que, effectivement, dans la partie données biophysiques qui explique souvent les analyses des tendances, des chocs ou des risques climatiques ou des facteurs de vulnérabilité, qu'on met en œuvre donc la valorisation des produits d'observation de la Terre dans le processus des analyses du cadre harmonisé. Et la démarche, c'est donc la méta-analyse et la convergence des preuves. Prochain slide. Comme je l'ai dit, donc, nous avons 2 groupes d'indicateurs, ce qu'on appelle les facteurs contributifs. Et là aussi, nous avons 4 ou 5 principaux groupes sous ce qu'on appelle danger et vulnérabilité, là où on fait l'analyse des risques. Donc, tout ce qui est question des risques climatiques, les risques sur le plan social, et tout ce qui est de l'analyse de la disponibilité alimentaire, en termes de production, et de l'accessibilité, l'accessibilité économique ou l'accessibilité physique aux aliments, et de tout ce qui est éléments d'utilisation qui expliquent donc les conditions favorables du maintien d'un bon niveau de la malnutrition ou de la nutrition chez les enfants et les adultes. Et nous avons la 4e dimension qui est la stabilité. Ensuite, comme je l'ai dit, on analyse ces éléments, ces 5 éléments en termes de leur impact sur les résultats de la sécurité alimentaire. Et tout ce qui est des indicateurs sur le résultat consommation alimentaire, c'est des données qui viennent des enquêtes régulières qui sont engagées au niveau des systèmes d'alerte précoce, au niveau des instituts nationaux de statistiques, au niveau de certaines ONG internationales ou nationales, et qui génèrent un certain nombre d'indicateurs qui sont utilisés dans ce qu'on appelle la table de référence. Et il y a tout ce qui est évolution des moyens d'existence. Là, on analyse, si vous voulez, les stratégies de mobilisation ou de recours aux capitaux des ménages pour pouvoir satisfaire leurs besoins alimentaires. Et nous avons dans un second groupe des résultats le statut nutritionnel et la mortalité. Et en général, ces informations proviennent des enquêtes réalisées par les instituts nationaux de statistiques ensemble avec les ministères de la Santé, l'UNICEF, et qui nous génèrent ces informations qui sont utilisées dans le processus des analyses du cadre harmonisé. Prochain slide. Alors, où est-ce qu'on valorise particulièrement les données d'observation de la Terre? D'abord, pour tout ce qui est danger et vulnérabilité. Et pour le dire, nous avons mis en place une task force qui permet de conduire les réflexions, de faire le développement et de voir l'articulation qu'on peut faire de la valorisation de ces indicateurs issus des produits d'observation de la Terre. Et la task force est constituée des experts du SILS, du PAM, de ACF, de JRC, Joint Research Center, de l'UNICEF. Et le pilotage s'est fait au niveau du centre régional Agrimet. Et nous avons défini un certain nombre d'indicateurs qui sont traqués pour expliquer les changements en termes de risque de vulnérabilité. C'est les anomalies de surface, c'est les attaques acridiennes, par exemple, les feux de brousse et les inondations. Et nous avons des modules qui permettent effectivement de traquer sur la base des imageries satellitales ces informations et sont valorisées pendant les analyses du cadre harmonisé. Pour tout ce qui est de la disponibilité, on analyse, donc on génère des anomalies de surface cultivée, des anomalies de rendement, et des anomalies aussi au niveau des biomasses qui nous renseignent tout ce qui est de la disponibilité alimentaire apparente ou de la disponibilité des biomasses pour le bétail. Et pour tout ce qui est accessibilité, il y a ce qu'on appelle les anomalies des animations des marchés. Et nous avons aussi tout ce qui est en construction aujourd'hui, puisque le Sahel, la région de l'Afrique de l'Ouest, est aujourd'hui embrasée par les questions sécuritaires. Il faudrait effectivement qu'on valorise mieux les produits d'observation de la Terre pour pouvoir générer des informations qui vont nous aider à faire des analyses holistiques, même dans les zones qui ne sont pas accessibles du fait de l'insécurité. Et en termes de construction, nous sommes aussi en train de travailler sur les anomalies, comment améliorer le fonctionnement des marchés et l'accessibilité aux ressources pastorales. Mais cela va nous exiger effectivement des images très haute résolution. Donc aujourd'hui, bon, il y a une question quand même un peu problématique de pouvoir accéder à des imageries très haute résolution au niveau de la task force pour pouvoir bien faire les analyses telles que nous sommes en train de vouloir le faire. Prochain slide. Voilà des exemples de produits que nous générons et qui sont valorisés. Vous avez les deux points là, c'est les deux zones particulièrement sensibles. Vous avez tout ce qui est la boucle Niger, Nigeria et Tchad à droite, c'est le bassin du lac Tchad, et nous avons les trois États du nord-est du Nigeria, Adamawa, Borno, Yobe. Nous avons la région du lac au Tchad et la région de Difa au Niger, qui constituent une zone d'intérêt du fait de l'accès limité, du fait de l'insécurité, du phénomène de Boko Haram. Il est difficile donc de pouvoir déployer des enquêteurs pour collecter les informations directement au niveau des ménages, et nous valorisons effectivement les produits d'observation de la Terre, les imageries satellitales, pour essayer de suivre les tendances de production et estimer. Et c'est des exemples, par exemple, que vous avez, qui ont été produits, par exemple, sur le rendement médian des 5 comparé aux 5 dernières années sur le 1000, au niveau du bassin du lac Tchad. Et à gauche, vous avez tout ce qui est de la boucle de l'Iptako-Gourma, qui réunit aussi le Niger, le Burkina Faso et le Mali. Et au niveau de chacune de ces zones, donc on essaie de traquer comment évolue le rendement, les superficies cultivées, comment elles sont en train de diminuer du fait difficile d'accéder à la terre, quel est le rendement potentiel dans les zones qui ont pu être mises en valeur pour le mil, le maïs et le sorgho principalement, qui constituent les principales céréales de base dans ces zones sous l'influence de l'insécurité et au niveau de la zone de boucle de l'Iptako-Gourma et du bassin du lac Tchad. Prochain. Donc, en dehors de ces produits, prochain slide, qui sont générés au niveau du centre régional Agrimet, nous valorisons aussi d'autres produits particulièrement provenant de JRC, provenant aussi du PAM, qui essaie de suivre la dynamique aussi des superficies abandonnées, mais aussi au niveau de la ACF, en tout ce qui concerne l'accessibilité ou la mobilité des animaux à l'intérieur de ces deux zones qui sont deux zones d'intérêt aujourd'hui sur le plan sécuritaire. Mais grâce aujourd'hui au recours aux produits d'observation de la Terre, couplé, triangulé avec certaines informations collectées auprès des ménages qui arrivent à se déplacer, à s'échapper, on arrive quand même à conduire des analyses holistiques, à faire des classifications de la sévérité de la sécurité alimentaire et nutritionnelle de ces zones, et qui permet donc d'informer les décideurs au niveau régional et de prendre des actions appropriées dans le cadre de l'amélioration des conditions de sécurité alimentaire et de la protection des moyens d'existence des populations dans ces zones. Prochain slide. Ce qu'il faut retenir, c'est que les produits d'observation de la Terre, comme déjà beaucoup l'ont dit au cours des présentations précédentes, aident à rendre disponibles les évidences pour les analyses des zones d'accès limité et inaccessibles, que sont la zone de l'Iptako-Gourma et la zone du bassin du lac Tchad, mais au-delà aussi, même les autres zones qui sont accessibles, des informations sont générées et valorisées lors des analyses de la construction de la convergence de preuves pendant les analyses du cadre. Donc, ces produits d'observation de la Terre permettent de renforcer la convergence de preuves pour la classification de la sévérité de la sécurité alimentaire et nutritionnelle. Il y a quand même des limites. Les limites sont surtout un accès limité aux images très haute résolution par donc, le centre, au niveau du centre régional Agrimet. Et je pense que l'une des occasions qu'on peut saisir, c'est de lancer un appel au cours de ce webinaire et au niveau effectivement du EUMETSAT, comment on peut renforcer la collaboration avec le centre régional Agrimet de façon à pouvoir accéder à ces imageries très haute résolution et qui vont nous permettre d'aller faire des analyses beaucoup plus détaillées avec vraiment des résolutions assez poussées et pouvoir suivre comment est-ce que les marchés sont animés, sur quelle fréquence et quelle est l'importance des échanges économiques entre les ménages et surtout aussi de mieux améliorer le suivi de superficies emblavées dans les zones extrêmement difficiles. Le partenariat donc doit être développé dans ce sens. Il y a l'exigence aussi, c'est déjà dit, à des équipements informatiques de pointe de très grande capacité et souvent qui font défaut et qui fait que on fait beaucoup plus de recours aux partenaires donc pour pouvoir faire des analyses de certaines imageries de façon à nous rendre disponibles. Et je pense que la collaboration qui est déjà avec le JRC et le PAM a permis vraiment d'évoluer positivement dans ce cadre en mettant à la disposition des analystes du Nigeria, du Niger, du Tchad, du Burkina Faso et du Mali, des données vraiment de très bonne qualité et qui permettent de renforcer la qualité du processus d'analyse. En termes de perspective, et donc le renforcement du partenariat autour de la task force produit d'observation de la Terre entre le CIL, SPAM, le JRC, l'ACF et FuseNet, et qui reste ouvert aussi à d'autres partenaires, effectivement, pourvu qu'on puisse évoluer vers l'amélioration de la qualité de l'information générée à partir des produits d'observation de la Terre. Et comme j'ai dit, comme perspective, nous avons aussi le développement de nouveaux indicateurs pour mieux construire la convergence, ce qui se passe sur le plan pastoral dans ces zones et ce qui se passe en termes d'animation du marché et de fonctionnement du marché, la disponibilité des produits alimentaires sur les marchés, comment les échanges se font, est-ce que c'est fluide, c'est pas fluide, comment on peut apprécier globalement la situation. Voilà, mesdames et messieurs, la synthèse de la présentation du Centre régional Agrimet. Merci.
Thank you very much. So we'll move on to our next presentation from Stella Aura. She's the permanent representative of Kenya with the WMO and also the director of the Kenyan Meteorological Department. She's going to hold a presentation on the concrete benefits of the National Climate Outlook Forum with a focus on agriculture. So please keep your presentations a little bit shorter so we can keep up time. Thank you. So Stella, the floor is yours.
Thank you, Mimi. Can you hear me?
Yes, we hear you very well.
Yeah, I take this opportunity to thank EUMETSAT and the organizers of the meeting for inviting me to participate and make a presentation. So my presentation is on concrete benefits of national climate outlook forums with a focus on agriculture. Next slide, please. So we look at the introduction and then the National Climate Outlook Forums. I'll give a practical example of Brookside Dairy Limited. Then we look briefly at concrete benefits of NCOF to Brookside and use of EUMETSAT data products in NCOF. And then I'll conclude. Next slide, please. So this presentation aims to present the benefits of the National Climate Outlook Forum through practical examples. And like I said, we are going to look at Brookside. Next slide. The Kenya Meteorological Department, with support from partner institutions, including the IGAD Climate Prediction and Application Center and Care International, introduced a National Climate Outlook Forum for each of the two major rainy seasons. The first NCOF was held in September 2020 for the short rains season, that is October, November, December. The second one was held for the long rains 2021. Next slide, please. Now, it has been realized that NCOFs could be one of the best user interface platforms, providing a forum to improve access, use, and application of seasonal forecasts. It also enhances dialogue and interaction between producers and users of climate information, and it also improves co-production processes. as it assigns stakeholders roles and responsibilities and strengthens multi-institutional coordination. Next slide. Normally, when we have an NCOF, we go through a GACOF, Greater Horn of Africa Climate Outlook Forum. We downscale our forecast to our country. Then we engage stakeholders through an NCOF. Some of the stakeholders include volunteers, government institutions, humanitarian agencies, all these private enterprises, and even individuals. Next slide. Next slide, please. Now, the NCOFs have been very useful in reviewing the performance of the previous rainfall seasons. Basically, what we do is that we review the previous rainfall season, and we look at the impacts on the various socioeconomic sectors and provide feedback on the lessons learned. In addition, the NCOFs have been used to assess the expected impacts of the seasonal forecasts, to develop possible adaptation and mitigation measures, management strategies, and appropriate multi-sectoral advisories on various sectors. Some of the sectors that we look at are water, energy, agriculture, health, environment, and disaster risk management. Next slide, please. After the National Climate Outlook Forum, or rather during the National Climate Forum, we moved away from the state where we used to make the forecast and just disseminate it to the users. So we sit and co-produce the forecast with the users according to their needs. Now, after the National Climate Outlook Forum, we continuously monitor the weather using various products, including satellite data from EUMETSAT, model data, and update the forecasts and issue warnings and alerts to the public, including the farmers, through various media. Next slide. With regard to Brookside, Brookside is East Africa's largest milk processor with operations in more than 12 countries. And it partners with 200,000 farmers, more than 200,000 farmers who deliver milk to it on a daily basis. Now, the Brookside dairy operations are focused on manufacturing of milk and milk products. In Kenya, the Brookside utilizes weather and climate information provided to them to advise farmers on various aspects with regard to the expected weather patterns. Next slide, please. Now, one of the concrete benefits that Brookside has derived from the NCOF process is that it has been, there's been successful adaptation of dairy farmers to the impacts of changing weather patterns on their dairy products using information from the Kenya Met Department. They use this information for restocking of livestock, conservation of excess fodder, combating emerging pests and diseases, stormwater harvesting, and even crop and livestock insurance. So basically, there has been improved uptake of weather and climate information by dairy farmers because of the NCOF process. Next slide. Next slide, please. Currently, KMD does not use EUMETSAT satellite data and products for climate monitoring. However, we note that the CMSAF data products are extremely useful for providing climatological data, and they are crucial for filling in gaps where there are limited historical weather observations. So we intend to use them in the future in the NCOF process and also in our in the development of our annual state of the Kenyan climate report. Next slide, please. So basically, NCOFs play a major role in improving the uptake of science within the societal decision-making process by enhancing long-term dialogues and interactions between producers and users of scientific knowledge. Weather-focused integration with satellite data and digital technologies has real benefits for climate change resilience building. The future of forecast-based decision-making lies in the co-production with key users, and in Kenya, NCOFs are facilitating this. Next slide, please. So I leave you with these quotes. We have a single mission to protect and hand on the planet to the next generation. And I want to thank you very much for inviting me to participate in this meeting. Thank you very much. Merci beaucoup. Asanteni sana.
Thank you very much, Mrs. Stella Aura. That was a very nice presentation. So I'm gonna just show you some of the answers from the polls. Just had before we move on. So these are the answers from where you're from, the institutions you work at, so you can also see it visually. And then also the answer from this poll. So if you multitask when you have a meeting online. So most of you do it sometimes. Of course, you're guilty, and there's only a bigger amount than I thought is 100% focus, so almost a third, which is really good. And what's the question, what the strangest thing you ever did when joining an online meeting was eating breakfast, as they tend to be in the morning, and other, the lips are sealed, so I'm going to leave it up to your imagination. Some of you wore pajamas, some cooked lunch or dinner, and nobody watched Netflix on the side, which is a very, very good sign. So thank you. So we now move on with our next presenters. Our next presenter is Gina Bon. She's the Director of Agricultural Planning in the Ministry of Agriculture in Seychelles, or the IOC, in the Indian Ocean Commission. And she's having a presentation of the role of climate monitoring for African SIDS, Indian Ocean. Gina, the stage is yours.
Yeah. Thank you. Thank you. Good afternoon from Mauritius. And probably it's just that I'm sitting here in my capacity as officer in charge and head of the environment sector for the Indian Ocean Commission. And my presentation will be very brief, and I'll just give a slight overview of the Indian Ocean Commission, because I think it's always good to recall who we are and what we do. Secondly, I'll give a perspective of the region, what the region is all about, and then we will go into the climate monitoring, and then I'll conclude. Next slide, please. Can we move to the next slide, please? Okay, this is the Indian Ocean Commission, and we have 5 member states. This is the Union of Comoros, Madagascar, Mauritius, Seychelles, and then we have France sitting in for the islands of Reunion. And when we look at the region, we have around 27 million inhabitants within the island states. And when we look at the some of the figures, you know, we have like 5.5 million kilometers square of exclusive economic zones. And also the landmass is approximately 1.6 million kilometers square. So how do we operate? So how do we work with our countries? It is, we are governed by a council of ministers. Then we have international partners with whom we work. And we also bring about regional programs and projects. Next slide, please. Looking at the context of the region, it is one of the hotspots of biodiversity, with most of the endemic plants, endemic species coming from Madagascar. And the region has over 1,500 endemic species, from what we understand. More than 50 protected areas and reserves, Coral reef is very extended, the mangrove forest, and we also, the region is also site to 6 natural heritage sites and Ramsar sites. It is estimated that the value of the biodiversity in the region could go as far as 20 billion USD. That's just an estimation. It can be a bit more than what it is right now. The main sectors, economic sectors, are the agricultural sectors, fisheries and tourism. And there is one sector that which is also of importance in this region. It is the financial sector. I'll come back to it to explain how it comes in with the climate. And also it is important to understand that the region is a very important marine sea route. So this is where we have a lot of vessels, traffic moving within the region. Next slide, please. This just again some information on the coastline. Why is it important in the context of the climate? We have it is estimated that there is 7,000 kilometers of coastline with a population of roughly 27 million people within on the coastal area, and the coral reef extends to 14,000 kilometers square. So when we look at all the ecosystem and we look at our coastal line, this is why it is very important in the context of the climate as we're speaking, because it can generate, the coral reef and the associated ecosystem can generate a lot of benefits, believed to be around 327 million US dollars. That is directly coming from the coastal and marine ecosystem. The tourism industry itself is contributing to 90%. They benefit from that. And we have 1.5 million people that rely on reef fishing. This is the artisanal fishing for livelihood. And it is also believed that we have around 3,000 small businesses depending directly or indirectly on the coastal and marine ecosystem. Next slide, please. And we also know that the region is one of the most, is the third most vulnerable region related to climate, with cyclone activities believed to be around 8 to 13 annually. But those that really mature into real cyclones would be around 2 to 3. And it is also what we have as records is that we have more than 100 natural disasters since 1964, and of which 90% are attributed to hydrometeorological related disasters. And what is also known for the region is that there are more intense rainfall. This is when we say more intense rainfall. It's rainfall on a very short period with it's very dense, very intense, but in a very short period. We've also noticed increase in temperature leading to extensive dry period, landslides, and flooding. Next slide, please. Now we will look at the climate monitoring for the islands. Why I brought all this information to your attention before, because this is important for us to see the context within which the Indian Ocean, the island states needs to have improved observation systems, because this is for us. Most of the countries, they are very small. The islands are very small and scattered all over the ocean. You have seen that the whole of these island states, they cover around 5.5 kilometers squared of the ocean. So this is very important. And we also understand that the climate in this subregion is highly influenced by the sea surface temperature. So what we have seen and we are observing over the years is that there is this. We have been using satellite images, satellite information to improve a climate observation system. And this is important to understand the trend, to understand the the pattern, because so that we can improve the weather forecast. And there are all the climate variables that comes along with it. What is important as well, that we have real-time data for search and rescue, and for we have experienced over the recent past the oil spill event in Mauritius, where the climate and satellite images were very important for the management of the spill. And it is also very important for developing response mechanism. And also for the climate, for the satellite data, we need that for the ocean parameters, very important for the ocean parameters. And because most of the people, we have a large community of fishermen within this region that depends on the sea. And as well, it is important for the safety at sea. So that's important for us to have more precise information, more precise data to improve marine forecast. Also important is to improve the early warning system. At the moment, I would say each country is at a different level in the early warning system. But what we are doing as a region is we are trying to bring the system into a multi-hazard early warning system and to reduce loss, and also help countries to plan better. Next slide, please. The sectors that are very sensitive right now, that we have seen very sensitive to the climate, is the health sector. This is especially now to do with the respiratory diseases, and also the epidemiology. And why I've put in the entomology. The entomology is very important because most of the diseases that we will be looking at as epidemics are related to they are vector. They are related to mosquitoes like dengue, chikungunya, and also malaria. And what is important as well for Madagascar, they are working on that right now, is the follow-up on for diseases related to the plague that Madagascar has known for the past couple of years. In agriculture, it's very important. It's being used for the farming practices, how to improve the farming practices, best to see how to monitor the pest control. That is, look at the best options for adaptation when it comes to pest and disease control. In the fisheries, satellite imaging is being used for the MCS, for the monitoring, control, and surveillance. And also, it is important for us to understand the parameters of the ocean in relation to the migration of fisheries species. When it comes to development of the coastal zone, we have seen that the infrastructures in most of our countries are based along the coastal area. So it is very important as well that we have information and correct climatic information for the development of the infrastructures, especially when we look at our ports. It is of importance to us. For the ecosystem, again, it is really, we all know that climatic factors may affect with the high temperature of the sea surface temperature, and rise in temperature may affect the coral reefs and also some of the other species. Next slide, please. So just a few words. It's the importance to invest in hydrometeorology. We believe that where we are right now, we need technology. Since our islands, they are so scattered all over the place. So we need a high resolution technology. We need to better understand what is happening in our system, in the climate system. Also, we believe that it is important to invest in human resources and have proper career guidance, and have a long-term training for to develop the capacity within the med services. It takes a very long time to train a meteorologist. If we start from, we look from the preschool up to university, we will probably need 15 years. So this is a very important, and to have a continuous training program to improve capacity. As the technology continues to evolve, we have also need to continuously upgrade the capacity within the institutions, and for them to better adapt and understand the changes that are going on. Next slide, please. And this is the last slide. Also, the message is to improve on information dissemination. You know, it is sad sometimes. We know that a lot of efforts are being put by the meteorological services, but again, how the public understands and they take up the information being given to them. So it is very important that we try our best to try and facilitate this information transfer. Also important to look at the interaction with the users. For the moment within the region, we have the Southwest Indian Ocean Outlook Forum. That this needs to be, it is a very important forum. It is a very important platform for exchange and collaboration, which needs to be strengthened. And also it is, what is important as a message is to look at institutional frameworks for adaptation and mitigation within the region. So I think, Mimi, I'll stop here. That's the next slide. That's it. Thank you very much.
Thank you very much for your presentation. So we move on to the last presentation for the day before we go to our small panel discussion. And it's a joint presentation from Ianis Proal from the Regional Humanitarian Affairs Office at UNOCA. And we also have Samir Belabes from the Division for Satellite Analysis and Applied Research at UNOSAT. And they're going to hold a presentation of the use of seasonal weather forecasts and satellite imagery by humanitarian actors. The floor is yours.
Thank you very much, Mimi. And thanks to EUMETSAT for this opportunity given to OCHA and UNOSAT. So my name is Ianis Proal. I'm working with the United Nations Regional Office for Coordination of Humanitarian Affairs based in Dakar and covering West and Central Africa. I will focus the first part of this presentation on the use of seasonal weather forecasts by humanitarian and DR actors. And then we'll hand over to my colleague from UNOSAT, Samir, which will bring us towards the concrete use of satellite imagery and data to better respond to natural disaster. Next slide, please. So over the past year, OCHA developed a growing but still new partnership with regional climate centers, such as ACMAD and now AgriMet. We need to know that the first ever discussion between humanitarian users and Met services occurred in 2017. It's still new. So this technical dialogue is now happening on a yearly basis in anticipation to the rainy season for presentation of the results of Met services. And we are now trying to develop and enhance the attendance of those dialogue between Met service scientists and users. The last dialogue took place 1 month ago, and you can see on the slide the main feedback from users. For now, unfortunately, we are still using Met services mainly for response purposes, and we are really willing to enhance our capacity to use the services for preparedness activities. And obviously, as Mr. Kamga presented, we've shown that the maps produced by Met services are covering a large areas, and we would need to enhance the localization of data. And this also comes with a better data sharing among Met services and humanitarian practitioners to ensure that this localization is enhanced and the use of data is better systematized. And at the same time, we are also trying to develop a more systematic dialogue on a quarterly basis with merge services and organize some after action review at the end of the rainy season. Next slide, please. We as OCHA are engaged in providing partners with information on humanitarian impact of disasters. Last year's, as Mr. Kamga presented, we faced a really above average rainy season, which led to a massive humanitarian impact. 2.7 million people affected by floods, etc. You can see those figures, and it's quite it has been quite a difficult season, and we faced massive response needs across the region. You can see that 18 countries have been affected across the region, and again we have been it has been difficult for us to anticipate those heavy rain episodes, and this is one of the main things where satellite imagery could improve our capacity to better forecast, our capacity to anticipate those potential disasters. And there are some room of improvement and challenges in terms of collaboration with Met services in this regard. So in the next slide, I will just list some key challenges we faced last year in terms of to produce the map that I'm just you can see on the right. Clearly, there is a lack of granular and consistent sources of data. We based our collect on CTRAP, rapid needs assessment, etc. But it's mainly a ground data, data collected on the ground, and we are not able to use systematically satellite data, which could greatly enhance our capacity to localize the impact of floods, for instance. In the same way, there was a lack of harmonization in data collection and a delay as well, because when a flood episode occurs, we have data available only few days or weeks after, and it caused some delays in response as well, which is a big limitation for us. And again, yeah, this lack of capacity to forecast sudden and heavy rain episode is also something that we would need to improve in the future, and the room for improvement. Next slide, please. As I said, alert is key, especially for heavy rains. We need to better identify hotspots, and in this regard, humanitarian do have data in terms of population density, vulnerability of population, recurrence of humanitarian consequences of floods and natural disasters episode, could be also droughts as well. And those data should be provided to Met services, and we should enhance our capacity to jointly produce maps to better enhance our capacity to anticipate and to work on early warning systems as well across the region. So the integration of those hotspots is key. To develop regular updates as well. In terms of bulletin, this is something that we need to develop not only on a regional perspective. You can see the map on the right, it's super broad. We are trying you can see on the corner, left corner, that we are trying to localize and zoom in some areas of concern based on humanitarian data and Met services forecast. Next slide, please. So this will be my last slide in terms of next step and area of collaboration with weather services and agencies. In terms of preparedness, this is an area where we are still weak, and we need to develop early warning system based on weather forecast in collaboration with NDMAs, weather agencies, and DR actors, basically. We need to integrate those hotspot analysis within the seasonal forecast. This is something that we are currently discussing with ACMAD, and enhance our capacity to integrate those short-term forecasts thanks to satellite imagery as well. In terms of response, satellite imagery is currently used, and Samir will present one concrete example right after. This is something that we need to systematize across the region, because it has been previously mentioned by other participants. We are intervening in a region where there is a lot of hard to reach areas, and satellite imagery is key to enhance and to plan response capacities for humanitarians. And in terms of after action review, we need to systematize the cross-check of weather forecast season and season performance after the rainy season to enhance our capacity to forecast and to prepare population to face climate episode. Sorry, it was a bit quick, but I'm trying to respect the allocated time. I will hand over right now to my colleague Samir for a concrete example on how satellite imagery analysis can inform and support humanitarian response in case of floods in DR Congo. It was earlier this year. Over to you, Samir.
Thank you very much, Yanis. Hello, everyone. So I will be try to be very concise and short on this to present a concrete example. So how satellite data can support emergency operation in DR Congo. Next slide, please. So I belong to, I think there is one before, probably. Yes, so I am from the UNITAR's Operational Satellite Application Program, which is an operational service that exists since 2002 and is one of the main activators of the mechanism of the International Space Charter to support the UN organization and UN member states. We have a headquarters in Geneva with outposted offices in Nairobi, Bangkok, and New York. Next, please. So this is a map that shows all the countries we worked on over since January 2020. So where we made over more than 460 products. We were activated 58 times over about 38 countries around the world. So everywhere we intervene, almost everywhere. Next. So now let me show you what we did in collaboration with OCHA. So we often collaborate with OCHA to support them with satellite analysis. For a concrete case in Lac Albert in DR Congo, where floods, somehow persistent floods were observed for several months, even after the rainy season. And then we were contacted by colleagues from OCHA to monitor the situation and see what is the impact on the population and the potential humanitarian impact. Next. So it's the Lake Albert that you all know. It's the borders between DR Congo and Uganda that we will see. I think many of you are aware of the situation along the shoreline of the lake, particularly the humanitarian impact that had over the DR Congo side. Next. So for this, so here is the timeline of when we were activated. So we were activated in 11th of February by OCHA, and then we provided a series of products that highlight the impact and on the villages, settlements, and population, and we could provide to OCHA an estimate of number of people that might be exposed to that rise of waters of the lake. Next, please. So here an example of what is happening in the coast of Lake Albert. So as we can see here on the images, a series of images between April 2020 and January 2021, where we see that waters have invaded a lot of parts of settlements, some fisherman wharf, etc. So it has really an impact also on the economical life of the region. Next. So here, a typical example of the products that we provide. So here we have a map that shows the evolution of the shoreline over a certain time over a specific settlement that was requested by colleagues, OCHA colleagues, and with giving statistics on the number of estimated population that was affected, and also the number of damaged house and the different shoreline position. The next slide will highlight these observations that we are doing. We did, and I think we continue somehow to monitor along the lake. And we can see here another village, how it was completely submerged by waters, and the different, you can see also there are some dashed lines that show the evolution of the shoreline over time. So we could also provide a monitoring of the cost. So the cost, how the cost moved. Next slide, please. And I think it's one of the last slide. And then at the end, so there was a series of observation along the lake. We could provide an overall picture to OCHA about what is happening along this lake in DR Congo, with estimate of villages, a number of houses damaged, so total number of population that might be in need in that region, and also the number of hectares that were invaded by water. So on those numbers, so were they really critical and important to OCHA to organize the humanitarian response in such a remote area, particularly difficult and remote area. This is somehow a rapid example that I provide here about the use of satellite images for humanitarian response. And then I hand over to Yanis for a final conclusion, very quick conclusion on this. Thank you very much.
Yes, thanks, Samir. Just a few key messages to conclude very briefly this presentation. Just to reaffirm that satellite data and imagery are key assets for humanitarian response. And we are currently using this for response, but we need to enhance our capacity to use satellite data for weather forecast and for preparedness purpose, and develop early action programming. Availability of climate-related data at granular level is key for us, especially in our region where we are covering a lot of outreach area and where we are not able to collect data on the ground directly. And in the end, need to improve the translation of weather forecast and climate analysis in actions and clear recommendation. And we are currently working on it with ACMAD and Met Services. Thank you very much. And back to you, Mimi.
Thank you very much. So now I'd move on to a very, very short panel discussion. So I'm just going to ask 1 or 2 questions to everybody. So everybody who just presented in the user part. So I'm talking about Gina, Stella, and Mr. Bauer, if you could all turn on your cameras too. So I've got 1 question for all of you. And we've heard how satellite data has helped you in your day-to-day. And you've also talked about, some of you have elaborated more on it, some a little bit less. So I'm going to ask you all again, what are the main challenges you faced in general? And what are the main capacity gaps in Africa or in your field? So I'll just continue in the presentation order. So I would ask Mr. Bauer to give his answer. Thank you. Mr. Bauer, your microphone. Thank you.
Oui, relativement aux questions soulevées ici, ce que nous avons, tout se fait donc, comme je l'ai dit, dans le cadre de la collaboration que nous avons avec les partenaires. Il y a non seulement ce que le CIRS élabore en termes de produits d'exploitation des imageries satelitales, et on match avec aussi ce que nous prévient le JRC et de FuseNet et du PAM. Mais là où nous mettons l'accent, c'est particulièrement les zones dans lesquelles nous avons des difficultés à pouvoir accéder physiquement pour la collecte des données. Et c'est ça, j'ai dit, c'est la zone des bassins du lac Tchad et la zone de l'Eptako-Gourma. Merci.
Thank you very much. The same question goes to Mrs. Stella Aura. So, hello, Mrs. Aura. Okay, if she can't answer right now, then I would give it to Mrs. Gina Bon. So, like, if you could say some words to this, thank you. We can't hear you, microphone.
Yeah, thank you. From where I sit, I work basically with the National Med Services. It's exchanges from them. And the information that I will relay comes basically from the challenges that has been conveyed to us. Using the satellite imageries for most of the Med services. Well, from what we understand, it is the frequency, how often, the time lag when the image, they need the image at a specific time. Maybe it arrives every day at 6, but for some other days, there is this time difference in transmission of the images. And also from what I understood from them, it is sometimes the information, the package of the information is not sufficient for them to be able to do the downscaling or to analyze or to be more precise in the information that they would want to relate to the public. So those are basically some of the, I believe as well it is to do with the technical issues, but using the interpretation of the data as well in certain cases would need, you will need a bit of more, it's a bit challenging in some cases.
Okay, thank you. So the same question. So what are the biggest challenges you face, and what are the main capacity gaps in Africa or in your field? So this question also goes to Stella. So if you're here with us now. Okay, if you're not here, then I'm gonna give it over to Yanis.
Yes.
And Samia.
Thank you. Just in terms of main challenges, and it goes well with the question asked in the chat by Alfred regarding the production of maps, including the people living in floodplains that can be mapped beforehand. Yeah, true. And this is something where we are seeing a collaboration area with Med Services as well, because we are able to know historically which areas are flood-prone area, mainly in cities. We can tell that in Bangui, this area is vulnerable, or in Brazzaville or so. It's more complicated, much more complicated in rural areas where we have massive displacement and people moving quite intensively. In DRC, for instance, where it's more difficult because people are moving more. And we don't have any data in terms of elevation and so it's much more complicated to map this, but definitely this is an area of collaboration where we want to develop those hotspot maps and then better forecast those heavy rain episodes across the region. So definitely this is a challenge, and at the same time where we want to go using satellite imagery.
Okay. Samir, are there also any other things on the technical side? Like what are the biggest technical issues and stuff you're also facing with monitoring areas there?
So we are not really, so we have a profusion now of satellite data. We have more and more satellite images. So even for the equatorial and subtropical zones, so we have more and more what we call radar data to monitor floods. But however, as Yanis mentioned, so monitoring floods within urban zones, dense urban zones remains an issue. Still, it's an issue because we need often very high resolution optical images, which can be cloud covered, etc. So in floodplains, it's almost okay, no problem. It can be done quite rapidly. So the main issue is really in urban zones, dense urban zones, where it's still, lack of, there is a higher uncertainty within urban areas. That's the main. And but we have more and more data over time, and we can think that in the next coming years, maybe even this this problem might be solved with new data, not only satellite, but also with more and more use of drones and all these new techniques. Over.
Okay, thank you. And Stella, what do you do? Like, what are the biggest challenges you have faced on your side with the satellite data? And also generally, what are the main capacity gaps you see in your field? Your microphone.
The challenges that we face basically with regard to data observation, ground data observations. We don't have enough stations. Currently, we're operating without a radar, which would really help us. We rely a lot on the EUMETSAT data. Another major challenge is with the users understanding the forecast. Because when you say there is 30% chance of a shower or that the rains will start on a particular date, because of climate change, we used to have the season start, say, mid-March. Now they're starting towards the end of March. So by the time you tell people the forecast, the rains will set in at the end of March, but people have already started planting. So there is capacity building in terms of public education and awareness, and of course, maybe upgrading of some of the systems. Thank you.
Thank you. Yeah, education is also key to making great change in the future. So I'm going to just have one last question. Just give me a very, very short answer. So my question would be, if you had any, like, one biggest tool to solve your biggest problem, what would it be? And I would take everything except money. So just a very, very short answer from everybody. I'll start again with Mr. Isufu Bawa. So if he's here, or if not, I'm just going to go with the people who are here right now. So I think, yeah, first I'm going to ask Gina. So if you can just give me a very short answer.
I think it will be technology, a goal for improvement in technology. And so that will go along with the training.
Okay. Same question to Sami and Yanis.
I will definitely say partnership with MED services, because for us it's key to enhance this dialogue. If money is excluded, I think we can start with this, and it will be a good start to enhance our capacity to forecast and respond. Thanks.
Thank you. So, Samia?
Yeah, I would like to say, so when you exclude money, there are a lot of restrictions. However, I would say reinforcing capacities, even if it requires as well money, but yeah, reinforcing capacities in the use of new data, new computing capacities, etc. Reinforce those capacities in computing, satellite data, etc. That might be really helpful for many in many domains. But yeah, that's what I will keep here, let's say.
And also, for Gina and Sami had very similar answers. Like, is it focused, like, when doing that, do you want to focus more on the educational aspect of it, or in the hardware and having the hardware to be able to do that?
I think both. We cannot. So the human capacities. And also the hardware. They go together now. So the use of technology requires absolutely the use of material, etc. So they go together. If we have only the brain but without the tools, it doesn't work, and vice versa. So it's. I think they're completely connected. We cannot disconnect them at all.
Okay, thank you very much. So Stella or Isufu, so the first one to come can also give me a short answer. Thank you. So Stella?
Thank you, Mimi. I think I would be looking at public-private engagement because this would assist to close the gap where we don't have enough resources. We would partner with other people, and this would cover issues of capacity building, capacity development in terms of capacity training of individuals and training of and acquiring of equipment. Thank you.
Thank you very much. So I'll now move on to some of the audience questions before we end the session. So the first question is from Cedric Elsie, and it's for Agrimet. And his question is, quelles sont les modalités pour un éventuel partenariat avec votre institution?
Alors,
This would be for Mr. Issoufou.
oui. Oui, pour au niveau du partenariat, c'est ouvert. Hein. Comme j'ai dit, nous avons mis en place une task force chargée de traiter toutes les questions relatives aux produits d'observation de la Terre. Et les modalités, c'est vraiment mettre en contact le point focal du centre régional Agrimet qui pilote, et puis être dans l'équipe de la task force pour poursuivre les discussions, les échanges et le développement des indicateurs souhaités au niveau du comité technique du cadre harmonisé. Il n'y a que ça à faire. Donc, manifester l'intérêt et puis c'est ouvert au partenariat.
Thank you very much. So there's another question from Mr. Trebosan, and it's also for him, for Mr. Issoufou. And his question is, quel pourrait être l'apport des prévisions saisonnières dans l'analyse du cadre harmonisé?
Oui, les prévisions saisonnières sont aussi prises en compte hein, parce que vous savez, nous avons ce qu'on appelle le réseau PREGEC. Et le réseau PREGEC, c'est le réseau de prévention et de gestion des crises alimentaires. Et tout ce qui est comme développement des scénarios sur les prévisions climatiques, il y a le compte rendu qui s'est fait au niveau du PREGEC. Il y aura le prochain, c'est la période du 17, 18, 19 juin. Et donc, toutes ces données provenant de forecasting, de comment le comportement de la saison, à la fois dans les zones côtières ou dans les zones du Sahel, va se comporter, quels sont les risques liés à cette saison. Donc, tout ce qui est des dernières assises des prévisions climatiques, on va faire le compte rendu et nous prenons cela aussi en compte dans les mises à jour de la situation alimentaire et nutritionnelle au Sahel. Il y aura une autre réunion qui va intervenir en septembre. Et là, c'est pour confirmer effectivement ce qui a été observé, ce qui a été prédit lors des prévisions climatiques, comment la campagne s'est comportée, quels sont les scénarios finaux auxquels on aura tendance à faire à la fin de la campagne agro-pastorale. Et tout cela aussi est pris en compte dans le système des analyses du cadre harmonisé en tant qu'évidence produite dans le cadre des prévisions climatiques. Merci.
Thank you very much. We have another question from Lucas Okaj, and his question is, any focus on marine life conservation in the islands of Indian Ocean? And that will be for Gina.
Yeah, thank you. Thank you for the information. In fact, what we, for the focus for the islands on the marine life, it is important that we understand the marine parameters in terms of the climate, sea surface temperature, the salinity, the chlorophyll. These are the information that we look for. And what we've been able to do, what we think is important as well, is that will help us to understand the extent of the coral bleaching, if ever, if there will be the coral bleaching, and what should be done at a certain point in time to mitigate this type of disasters. And also we are looking at the mangrove forest along the coast to have the sensitivity maps of all the the marine ecosystems using the Earth observation technology. I don't know if I've answered your question, Sam.
So like if you have any, like if you still have a question, you can still put it up on our Slido. We'll have to end the question and answer. Unfortunately, because of time, we're already over time, but you don't have to worry. The questions you've posted on Slido are also going to be answered even after the webinar is over. So like also the presenters, like after this is done, you can also go over to Slido, and if there's still some open questions to you, you can please answer them. So as we come to the end of this webinar, I'd like to thank everybody. So I want to thank the presenters, all the interpreters, and the participants for taking part. Please also mention this event on social media, again with the hashtag EOAfrica or at EUMETSAT. You can also find the recording to this on YouTube afterwards. And I think before we totally close everything, I'll please ask you to turn on your camera so we can make a group photo to remember this event. So if you could all turn on your cameras shortly so we can take some pictures. Thank you, so we can also see all your faces. So I'm going to wait a bit. Everybody, all the participants, and all the speakers, thank you. So let's make some screenshots. Perfect. Thank you very much. So, and also have some information for you. So if you also request a letter of attendance, you can just write us an email. So the email is going to be put into the chat if you need it for your work, and then you're going to receive it. So thank you very much, and I hope you enjoy the rest of your day.